Okay, thank you, Tom. Many thanks for having me here again. This is now the third time I'm taking part in this summer school, and I hope I can transfer some machine learning knowledge to you. So, what I prepared, as Tom said, I should introduce myself and so on. So I prepared one slide, if it would. Okay. So I'm a geographer. I'm clearly coming from the domain knowledge side of this discipline, and I'm not a statistician or a math person. So if it really goes into the details, maybe I'm not exactly the right person to ask, but I can still try to answer your questions. I have a diploma in applied statistics and also did a PhD in that field. My current position, as Tom already said, I work for the Bern University of Applied Sciences. So this is a university that is less focusing on publishing papers, but is more focusing on knowledge transfer into practice. And I'm in the agronomy section in the soil research group. My focus is really on interdisciplinary research at the intersection of GIS, soil science, and statistics. So I'm working on spatial modeling of soil properties and improving and digitizing the soil surveying process. Also, I work on data handling in the field. So we are currently developing an app to record the soil survey in the field directly. So, and during my daily work, I really encourage people to use free and open source software. And yeah, we still have a lot of people at the university that focus really only on ArcGIS, and I keep encouraging them that the world is a bit broader than that. My main language is clearly R, but I'm also into QGIS, LaTeX, Saga, Grass, Open Layers, which is something like Leaflet, but a bit more broad, PostGIS, Inkscape, Git, and my computer runs Linux. So just instead of already showing some content of this afternoon, I just put one slide, what is coming after. And after that, I will show you an example of my work. So the first block of my talk at 11 is going to teach you some basic concepts. It gives you an overview of the machine learning methods that are widespreadly used, these tree-based methods, random forest, very widespread, but also machine learning based on linear models, generalized additive models, and I will also show bootstrapping, boosting, and model averaging, basic concepts of machine learning. In the second block, we will go a bit further and we'll have a look at what Tom just mentioned, like these partial dependence plots, covariate selection possibilities, and also how to map uncertainties for machine learning methods. These two blocks, they will be both structured in a quite traditional lecture, and I would already like to encourage you, please ask questions, don't be shy, please be interactive. And there will be a hands-on exercise that might be a bit too big to go through all of it, but we will see how far we go, but you still have the codes. So it's always good, even if you work in a completely different field, it's always good to see an example of someone else's work so you can get inspiration for your own work. So what I plan to show is some of my current work, and I tried to use quite old soil maps and tried to use as much information from them as possible. So I was once giving a talk, and there was someone from the Ministry of Agriculture of a rather small canton in Switzerland there, and they are in need of soil maps, and they have soil maps for a certain area already. And they approached me and asked, what's the next step? What should we do? And I proposed them, well, try to get everything together you already have, try to get as far as possible with that, and collect a proper validation sample in the field to check if this is how far this can go, and then you can assume what's the gap for your like map to be completed, and like this you can then like estimate the cost of like covering the whole service. And for them, the main focus is they want to update the tax values of the land. And quite a large focus is the protection of the good quality arable land, which is has now a strong legal basis that it uses soil maps in Switzerland. So the situation looks like that. Just for your personal orientation, that's the location of the Rhine Falls, and this canton is mostly to the north of that. And the orange part is the area that already has been mapped, roughly 1/3 of the arable land. And the bluish together with the orange part is 120 square kilometers have not yet been mapped, and there's no soil survey data there. But to the south, we can see we have as well already a soil map in a neighboring country with a similar soil survey. So my idea was basically, but if we check, this is a geological map. I did not put any legend, but already from the colors you can tell, well, it's not all very similar, especially to the north. We have like some other geological units there, like calcareous rocks from the Jura Mountains come in, whereas in the south we have more glacial geological units. So, but still, I proposed to try spatial extrapolation, and that's what Hannah already presented. Of course, we have to be careful with that. That's why I also clearly proposed to do a field survey to check if this is worth anything in the end. So that's a picture of one of these old soil maps. They are from the mid-80s. To the 90s, they have been surveyed and really drawn on paper, and this is like old surveys have been. It's polygons, it's not raster. And if we have a look, these polygons, they have the content is like encoded. It's all optimized for a process that is not digitized. It's optimized for writing very little. It's all coded and so on. And for all these codes, we can find further information in a legend booklet. So if we have this code, I can find information, and it's all written. It's no numbers. So, but if I check, I can translate all these prose into numbers, and I find value ranges as well in this legend booklet. So with these value ranges, I all digitized that into a table, and I was quite able to harvest some soil properties out of these descriptions, but it remains value ranges like clay from 0 to 10% or gravel content. It's always a value range. I don't know the exact number. So, and then I have a further problem. By then, it was like with polygons, it's very difficult to like map the small scale variability. So if it was not possible to have like separate polygons, they would even assign more than one of these mapping codes. So they are called complex polygons, and according to the legend description, it would be the weight of this color coding, but I could not be bothered to measure that, so I just assumed it's like a 60%, 40% weighing scheme for these codes. So what I then did is like create virtual samples, because when this map was actually drawn, they did do a lot of augerings, a lot of field survey, but they were not recorded with their coordinates because nobody had a GPS by then, of course. And so I was like, I created virtual samples by just putting points by sampling strategy inside the polygon. And then I selected if it was like, it had like more than one of these units. I selected one of these at random, but weighted by this percentage. And then I assigned out of this value range that was represented in this polygon, I assigned the value from 10 to 20% here, for example, 11. And I assumed the uniform distribution because there was no grounds to assume anything else. Then I repeated this process. And of course, this gives me then within a polygon several of these like virtual augerings that have, for example, here for clay content, different values and different locations, of course. So this, according to this map, that's what I should find in the field. But of course, these maps also have a certain, they have uncertainty. It's written in the booklet like 10 to 20% of this polygon can even be something else. So we don't know. Now, let me first show this. Now, how do I actually put these points into these polygons? So I tried different sampling strategies. First, the simple random. This is like usually used as reference design. Then I used stratified design and conditioned Latin hypercube sampling design, as this was quickly and easy to implement. And for this, I assume you're not very familiar with that. It is a design where you cut the number of strata is the same number of points you want to sample. If you sample like 200 points, you have 200 strata, and you cut your feature space in 200 strata. And this means if you can not just use like one or two covariates for stratification, but you can basically use all of them. That's what then results in a hypercube, because it's then like a multi-dimensional sampling over your complete feature space. And it's conditioned, of course, because not all of your combinations of your value ranges do actually exist in the real world. For example, some geological units, they only have steep slopes, they don't have flat slopes. So it's only sampling what's actually possible. And then it's, for me, it's like a little bit like a Sudoku. It's only sampling each combination once. So in every line, in every column and in every row, you just can have one sampling point. So what I did a simple random sample just for the soil maps of Schaffhausen, just within the same canton, and also a second within the canton to the south, because these areas are not so similar, and I thought maybe this might be an advantage. Then the stratified random sample, I did not use like the coordinates for stratification, but I used the geological units, because the soil surveyor told me that's the main, one of the main influencing factors. And of course, then the conditional Latin hypercube sampling and the number of samples, it's not so clear. So I tried different number of samples up to 35,000. This would mean I have roughly in my area, I have like, or the maps I used as a basis are like roughly 35,000 hectares. And I assumed to create these maps, they must have taken a sample maybe every hectare. That's why I put the upper limit.
Can you show the scope of the whole area at once?
Yes, at once. So I did 30 repetitions of each sampling strategy of each number, and I fitted like separate models for each soil property. So far I fitted for 2. I will show you for the clay content. Then I just applied a very simple random forest. I did not do any tuning so far, just as a first try. And as covariates, I mainly had this geological map and simple and also quite complex terrain attributes, and the rivers, the river map, so vertical and horizontal distances to rivers. In the end, I worked with 10 meters resolution to create the predictions. And this is already the resulting map. And as you can see, this is for topsoil clay content. For here in the south, where we already have a soil map, you can see quite some differentiation. But here in the north, these small lines, these are the agricultural roads. So within one parcel, there is hardly any variation. So this means like outside of the area where we extrapolated, it's difficult to map any variation. But as you remember, the content of this map were always value ranges from 10 to 20%. So, and sometimes that it even stayed like from 10 to 30%. So the value ranges were very large. So it's clear that input data is very widespread over my target response. So for a first validation, I have first of all these orange dots. They have been used in the late 90s to create the original soil maps, and then we sampled new spots in March of this year. With we had like 2 days, and we just went there, and so we took like a nested sample to have as many sampling points out of these 2 days. So, and this is the validation R-square that I computed for these different sampling designs, and here you can see also that these different sampling numbers. And on first sight, this is for clay content in the topsoil, and this is the rootable soil depth. And you can already see, I mean, like with an increasing sampling number, the R-square increases. So like creating a lot of virtual samples, I might even go up with the number even more. But on the other hand, on a total picture, you can see it really depends on my response variable. So clay content on average has an R-square that is above 0.5, and this rootable soil depth, I quite have a difficulty to predict that. Overall, it seems like if I do a random sample, I would have expected a complete random sample is usually inferior than a stratified sample. But these random samples are now for both responses are a feasible way to go instead of using like a complex sampling scheme. Excuse me, this is the results on the 200 that have been used to create the map. And now this is the result on the 50 new ones. And I will get another 300 new ones by the end of the year. And they will be collected with a random sampling design. No, the 200 are the original. And the 50 are from this March. But still, for clay content, I was really astonished. Andreas? The conditioned Latin hypercube I took over Schaffhausen and Zurich overall. So only Schaffhausen is this random, only SH for Schaffhausen. And stratified is also overall. But this was since some strata do not appear too much in Schaffhausen, the ones from Zurich do not get sampled that much. I was actually, this is now really the points that lie really outside. Maybe I go back, really outside of the mapped area. The mapped areas is just where we can find these orange points. And still for clay content, I'm really satisfied. I was astonished because we are really in an extrapolation situation. I don't have any points in this area and the geology is quite different there. But for this rootable soil depth is completely off. So and my model is a random number generator. Exactly for this extrapolation situation, I cannot see this behavior anymore. And with 1000, it's about the same. I mean, the variance increases in the repetitions, of course. Yeah, exactly. But for this rootable soil depths, I have also a clear indication that the samples we took, like this year, the procedure how to record this rootable soil depths has changed over the last 30 years. So it's the response is actually not the same anymore. So here I also briefly show the bias, and I show the ratio of the bias square to the mean square error. And it's on average, it's about roughly like 10%. Here it's quite low. I'd say that's okay. But if we see now for these new samples, we have quite a high bias. That's like the part of the bias of my root mean square error increase. So that's what I would expect for an extrapolation situation, that I'm some sort of a bit off systematically. So in general, I mean, one can give a try for such an exercise, but really be careful. And I would not have done it if I could not have sent someone to get me new samples to really properly validate it by the end of the year. And it seems it really depends on your response. It's very difficult to get a generalized, a general approach out from that. And from the sampling design within this study, I could not really take a decision. So, as I already said, I will do proper validation by the end of the year and also try to integrate some more covariates, as they might give me some interpretation of the crops that are grown, some maps of them. So many thanks to the people that were involved and also the funding of the canton of Schaffhausen. So are there any questions? This is the predictions of the rootable soil depths, which has for the exact same area shows also some variation within. But this I actually really don't trust. And those are the predictions of the clay content. And you mean like the modeling process?
Yes.
No, I did not use. I used the Ranger directly. Yeah. Yeah. Yeah, but I did not do any tuning. And the rest, like the sampling strategy and so on, this would not be implemented in Carrot anyway. So you would need to program it anyway yourself. As I might introduce some tuning, but I don't know it. I mean, it's since I do like 30 repetitions and I did like many repetitions on the sampling design, I have to reduce the repetitions there to be able to any tuning. It will be a different data set. This is a bit too difficult data set because it has so many specialities. No.
some data set you can use.
Yeah, most the data sets I mostly work with, they're like real world data sets, and there are always flaws in them.
Any questions from Madlene?
Just by the mean error, without mean error, yes. Yeah, because I use it on the level of the variances. This means I compared the bias square to the mean squared error, not to the root mean squared error. Because the variance decomposition, we will see that later on, is on the level of the variance, not on the standard deviation.
So when you have the second popular separation, so what is the threshold of this separation?
Yeah, it's difficult to say in general, because I'm in a setting that I want to map like multiple responses. They're not satisfied with just clay content. They need like a bunch of like soil properties to evaluate the usefulness for as an arable land, and therefore you always have to see that in like the whole picture. But I mean, here it's going up to like 40 for some simulations, up to like 60% even, and I think that's like serious problem to look into.
And does it make sense to you when they see if you have less points, you have less bias, which would be by accident, because you will expect that you get more points that the bias will drop a bit, you know?
If I get more calibration points, I expect the bias to clearly drop.
Yes, but I see in some cases it's even going up, like all that, you know, it goes up and you have more.
Aha, for yeah. Yeah.
So maybe we should like after this, you like a fixed newspaper or something. Okay. How the person understand the bias will drop that you increase the
Yeah, but basically I cannot drop the bias because my samples are always taken from the same area. It remains an extrapolation situation.
US is more stable than the bias. Okay, where is this? How do you understand the plots?
This this is it was just possible to do this box plots because I had like repetition.
Okay, but how would you call them?
Yeah, it's I'd say model performance as a complete picture. It should always include also bias.
Okay. More questions?
But first of all, the soil map units, they only contain these value ranges I would have needed to decide. And secondly, my terrain attributes, they vary within one polygon. And so I always can have a look, it's the only possible way is to look at a certain point and then to collect my covariates there. Because I have, otherwise I would have needed to take like the mean curvature within a polygon, which is then smoothing out my terrain attributes. But basically it follows this disaggregation procedure that was proposed by Ochers. and it's based on that same algorithm.
Why do you have just but fantastic work. We're simply happy to have you again, and I look forward to holding this soon. And then so sometimes the best way to teach people is to show them this example. If things don't work, I can put the answer 0 and then I have to fix and bye. So it's the best way to data science. So we look forward to it. So thank you. So I'll take you take over here. I'll switch to the second presenter of the day, who is still in Germany, but we will connect virtually.
I switch that off.
Yes, you can switch off. So, Tim, are you with us?
Yes, I am.
So you can, I think, I will stop the screen sharing, and you should be able to do screen sharing from your side, and you just have to turn on the camera.
For the camera, it says you cannot start your video because the host has stopped it. So.
Okay, now you should be able to turn on the camera and do the screen sharing. Please try now.
Yes. Good morning.
Okay.
Screen sharing.
And so please try to keep it to about 20-25 minutes so we can still ask you some questions.
Sure, no problem.
Okay, so we see the screen, we hear you perfectly, so you are ready to go.
Sounds good. Thanks, Tom. Good morning, everyone. And I'm really sorry I cannot be there in person. But work got in the way and other things, so I really couldn't make it this year. I hope that I can come back next year if Tom invites me again. So today in these two sessions, in the morning and in the afternoon, I want to introduce the package mapview. I hope many of you know about this package already, but I'm fairly sure there's functionality in there that many of you don't know, and so we're going to go through this in a very hands-on manner. So basically I've prepared two scripts and we're just going to live code through these line by line. Now my name is Tim Appelhans, but don't worry about the last name. People get confused about my last name anyway. And there's two people because mapview is a collaborative effort. As you can see on the GitHub page, there's many contributors. I'm sort of the main guy who keeps the whole bunch together, but there's contributions from all over the place. But two people I really want to thank because they've been involved from the very beginning. Two ex-colleagues of mine from the University of Marburg, which is Christoph Reudenbach and Florian Deitsch. And Flo is actually still my colleague where I work now. So for this morning session, there won't be any fancy lecture theoretical content. I'm just going to tell you a bit about myself, and then I'm going to tell you a little bit about the history of the development of mapview. Why did I start the whole project and what has it become now? Then I'm going to also quickly show you what's in the pipeline. So next steps that are going to happen at some stage, because you need to realize I do this in my free time after my work, during the week or on the weekends when I find the time. So virtually, as I said, don't worry about my last name, just call me Tim. Virtually, my last name is always Salabim, apart from my email. But on GitHub, you can find me at Tim-Salabim, or I'm also part of the RSpatial GitHub organization. And for the RSpatial, mind the minus between the R and the spatial, because there's another RSpatial without the minus that is by Robert Hymans, the raster package or Terra package developer. on GitHub, you can find me on Twitter. You can find me at my handle at timsalabim3. And if you have any specific questions that you don't think are for the wider public, you can always email me at timappelhans@gmail.com. So where do I come from? I'm a trained geographer. I did my diploma, as it was called back then, so basically a master's in geography at the University of Erlangen-Nuremberg. Then I went on to New Zealand to join the University of Canterbury to do my PhD, also in geography, mainly about air pollution research and climatology. And that for me is quite a defining time, because that's when I was introduced to R and basically fell in love with the language. And ever since, my endeavor to becoming an R developer and contributor to a wider community basically started. Then I went back to Europe and joined the environmental informatics group at the University of Marburg. That's also the time when I started mapview development. And I was there for quite a while, 6 or 7 years, but at some stage I thought, nah, let's try something else, and joined the GfK in Nuremberg, where I live, so back to home, as a geodata scientist, and stayed there for 2 years, because then I got an offer from a company called Meter Group, and that's where I work now. And there I'm basically establishing a newly formed data science group to augment what the company does in a virtual and data science way. So Meter Group, I've put the link there, not as a sales pitch, but just because it might be interesting for people in the environmental sciences realm, because Meter Group produces environmental sensors mostly related to soil moisture, soil metric potential, and all that kind of stuff. Plus, we have quite a nice atmospheric climate station type sensor setup. And also, we offer to host your data on the cloud and augment it with information gains that we try to provide in our data science unit. So maybe that's worth checking out for some of you. Why did I start to develop a package that provides interactive visualizations for spatial data? Well, because I was working with spatial data all the time at the time, and that was back in 2015, and I was mainly working with raster data. And R has in general no built-in interactive plotting functionality. That's one thing, but I felt, and it was standard at the time in QGIS, ArcGIS, that you have interactive plotting for your spatial data. But I was annoyed by having to switch between R and QGIS when I do my analysis in R. Then I had to switch to QGIS, so write the rasters, open them in QGIS just to quickly look at them, and then go back to R, do some more analysis, and check another intermediate check, open QGIS again, and so forth. And then I went to Aalborg to the Use R conference in 2015, and Joe Cheng from our studio presented his leaflet package that he just released. And immediately it clicked in my head that we can now turn our studio into more of a GIS-like or GIS-like environment. But at the same time, Leaflet is very verbose. So in order to get a map where you can query attributes and get the full picture of your data, you have to write many lines of code. And you don't want to do that all the time, because then it's quicker to just open QGIS and drag and drop the layer onto it, and you get that all for free. So I started out to just say, okay, let's write an API that just wraps these leaflet functionalities in basically a one-liner. as I said, we want to, especially during the workflow, and that's what MapView is for. It's not intended for creating presentation grade final maps. That's where I would recommend using Leaflet for, or even TMap. MapView is really just for you to quickly and dirty visualize and check your data in a quick manner. It has one advantage over QGIS, I think, because you don't have to explicitly load background maps. They just come with it naturally. And these can be a great visual aid if you want to know where on Earth you are and are your geometries aligned properly and all that kind of stuff. And for me, at least, creating plotting packages is fun. Now, if you want to sum that up in a one-line tweet, you can do like Charlie up there. Why do you use MapView? Because you need a map now, basically. And Charlie allowed me to use this quote here. So as I said, I started this in 2015, immediately after the UseR conference, or I think I even did this already during the conference. And a first commit that I made was basically this one, which at the time was still called the raster view, because I said I used to work with rasters all the time at the time. And that was just a few lines of code that would just wrap what I needed at the time in basically a one-liner with not many arguments that you could adjust. A few days later, I wrote what I think was my first ever email to the RSIG Geo group, and that was quite important in terms of me being a presenter here, because as an answer I got from Tom to this email was that he invited me to Lancaster to what was called GeoStat summer school at the time, to give a quick talk about this MapView thing that I came up with there. So that's how I ended up being a lecturer and even be more involved in the Open GeoHub Foundation now than I have ever dreamt of, really. In 2020, so now, basically, MapView is a full-blown package on CRAN that has a lot of dependencies and reverse dependencies and recursive dependencies. Probably I say too many, and I'm trying to thin that out a little bit. You see in this very messy graph, like how all these things come together, and that's only the imports and the depends. So I omitted the suggested packages here, because then you would have just seen a red mess without being able to read anything on this. The most important for me packages that constitute MapView are LeafM, LeafPop, and LeafGL. These are all based on Leaflet, but like expand the Leaflet functionality in quite a way. And basically LeafM is the working horse behind MapView. And obviously Leaflet, because without Leaflet, nothing would be possible. So what do you get when you use MapView? The thing about the plot function that is really nice is that it just works for pretty much every object that you have in R. Like there's a plot function for pretty much everything you do in R. And that was my intention, to generate a interactive version of this for pretty much every spatial data representation that you can imagine in R. I mean, a plot like this is quite nice. It gives you an overview of the different attributes colored in a certain way, but that's pretty much all it gives you. If you do the same with MapView, so you just switch plot for MapView, you get an interactive, queryable representation of your data that you can basically ask questions. You can interact with your data. You can zoom in, zoom out. You can change the background maps. You can do the pop-up queries, which will give you information of all the attributes that are behind a certain geometry. And you get mouse coordinates. So whenever you move your mouse up here, you see where you are on the screen. And that is just a much nicer way, in my opinion, to interact with your data. And as I said, you should be able to throw pretty much anything, and with anything I mean spatial data representation objects, at mapview, and it should work. I'll show you the methods that we have later on. So in general, mapview is, I always refer to it as a data-driven leaflet API because it tries to be smart. You don't have to worry if it's lines, polygons, points, or rasters. It will just figure that out for you and call the respective and correct representation to create the map. It is, for the most part, a one-liner, but it's still quite customizable. You can quickly add objects or layers to your map by simply concatenating map view calls with the plus operator. As I said, it supports many spatial types, and you also get global options. So you can change the way map view behaves globally for the duration of your R session. So you don't have to do that every time you call map view. I'll show you how that works in the tutorial today. Then more recent developments that have happened over the last few months. Thanks to COVID, basically, I had enough time, or I had lack of other things to do in the evening. So I sat down and started programming quite a bit. We now have data streaming onto the map, which you see up here on the top right, so that the map just basically loads successively and the data is streamed onto it. That makes for a nice experience because the map is just generated quite quickly. We can now scale. It now scales quite a lot better than it did before for large vector data, because you can use either LeafGL or even MapDeck as a rendering platform. I'm not going to go into detail regarding the MapDeck rendering platform today, but it's there. We have a very, very alpha release of support for large rasters, which basically leverages a leaflet JavaScript plugin that does on the fly nearest neighbor interpolation, which is great because you can really view large rasters without too much of a performance loss. And we have a new operator, basically just a vertical dash to compare two maps. I'll show you how that works later on. So what's next for me? I think in the coming months, I will be doing a lot of JavaScript and not much R, because I really want to divert as much functionality to JavaScript, because that means that things will be quick on the R side and we don't have to prepare data that we might not need, because the thing with interactive or with interactivity is you never know what the user is going to do. Is he going to zoom in? Is he going to, I don't know, switch layers? So all that stuff, if it's happening in JavaScript, only happens when the action occurs. I need to work on the adaptive rendering of large rasters, which will be based on stars objects, because that's just alpha at the moment. I really want to make LeafGL work together with flat GeoBuff, because that is like, that would make for an awesome experience for the user. There's still issues to be ironed out related to data attachments, because R is great and RStudio is great, but at the same time, they've introduced all these rendering platforms like Shiny and R Markdown that you also need to take care of. And there we have some problems at the moment. And I want to rework the pop-up tables, and there's a bit of a hiccup that they don't work properly at the moment, but we'll see that in the tutorial as well. Then I want to drop the raster dependency and convert everything internally to stars, just because it makes sense, because like the raster data representation is basically a subset of what stars can do. So it makes sense to use stars. I really want to make MapView more speedy, so speed up the whole code. And there's some things in the pipeline by a guy called David Cooley. He has some awesome stuff in the pipeline. So stay tuned for that. MapView also has an automatic renderer, as I call it, so you don't have to call MapView explicitly anymore, but it will just update your view whenever you change your spatial data that is in your global environment. So it's like automatic plotting that you know from QGIS. Then I'm thinking of integration of space-time data using a package called Leave Time, because at the moment, MapView is only for geospatial data. And then there's a few more internal things. The package down update is already underway, thanks to Patrick Schratz. And obviously, I'm always open to feature requests by anyone. So that's pretty much it from my side this morning. Thank you very much. And you can find the code and the slides of this presentation at this GitHub repository. So just clone away and use it today in the tutorial. Thanks.
Thank you. So thank you. We still have some time, Tim. Thank you so much for that. And thank you for dedicating your whole day today just to contribute to this summer school. And absolutely thank you to your contribution via this package and helping people visualize their data and making them connect with their data more easily. So you see we have a full room of participants, and so we are looking now for questions. So let's see if there are any questions or reflections. Yes, Madlene? Yes, the package is very cool from Madlene Nussbaum. So you get a few thumbs up here.
Thanks, Madlene.
So my question, I have a little question for you. So we started now doing a lot with the cloud optimized geotiffs. So it's really brilliant. You put the whole data in one file, and it's it's very fast to visualize, to query. So is there any support? Does it make it easier for you if we have a cloud optimized geotiff to use MapView to visualize it?
Well, it's in the pipeline, let's say it like that. So the new way of rendering rasters, as I just said, that does the on-the-fly interpolation of the data in the browser, can read cloud-optimized geotiffs. So you can, like, I imagine in the future, in the near future, there will be an option to just call MapView with a string representation of the URL, and then that would just stream into the browser. So okay. Yes, that should be possible. But as I said, this is all JavaScript, and I'm not the best at JavaScript, so bear with me.
There's another question by Madlene. Why did you use leaflet instead of open layers?
Simply because there's no, or there was no R wrapper for open layers. And I have, like when I started, I had no knowledge about JavaScript whatsoever. So I could only do the R side. That's all I knew. And that's why leaflet was the only option, basically.
There's no package for open layers in R at the moment.
I think there is, not on CRAN, but there is a GitHub package somewhere. But I think development has stalled for a while there now.
And one more question. We had a discussion, I think, in Prague already about going from R to cesium. So you can you do like a virtual, so like a 2.5 or 3D GIS. Any progress there, or is it still just a dream?
No progress there. It's
okay. Well, at least we have excused this pandemic, so we're not so productive.
Yeah, well, at least in the end, I'm more productive in this pandemic because I get more time to do it like on the side of my job,
Yeah.
right?
But we could now, you know, we don't have to, like, of course, there's a core group of developers are spatial and make most of things, but maybe we could publish that idea or make it as a task, maybe for some other summer school, and then offer a scholarship if somebody steps up and makes. What do you think? What will be like? How complex will it be to make a, you know, map cesium or something?
Well, we have a cesium package on our spatial already, and that
Okay.
supports like one layer of vector data. So you can pass it a polygon object, SF object, and that will produce a cesium representation of that layer in the browser. So that works. But
Okay.
fiddling around with all the details and all the functionality that Leaflet provides, that's going to be a big endeavor. And I think that's what the aim should be, because people are just used to that now, right? So layer switcher, changing the background maps and everything. At the moment, it's just a virtual globe with, I think, satellite image background. And you see your data, but you can't, there's no pop-ups, there's no labels, no nothing.
Okay.
But it's a start.
Okay. And what about this flat GeoBuff, the format for vector data? Basically, they call it cloud optimized GeoTIFF version of the data format for vector data. Tell us something about it. What are the advantages? Why do you started using it now?
Well, for mapview, the biggest advantage is the data streaming, obviously, because if you have large data and you don't use streaming, it takes a while for the map to render because the browser has to read all the data. With flat GeoBuff, the map renders instantaneously, and then the data gets streamed onto the map, like you get with QGIS, for example. So that's a much nicer experience for the user. And it's fast. It's because it's a binary format, it's really fast.
Would you recommend to everyone to, like, if they exchange vector data to, or like anything which is like a bit larger data, to use the flat GeoBuff as the universal data exchange?
Well, that depends on what you need, because it can only do one layer at a time. So it doesn't have, like GeoPackage, you can put many layers in there. If you need many layers, flat GeoBuff is not yours. But if you only have one layer and you want to be quick, and you have GDAL 3.1 or higher installed, because before that you would need to compile from source, or there's no support for flat GeoBuff because it's a very young file format.
So GDAL 3.1, GDAL 3.1, and then if it's just a single feature, then you use flat GeoBuff. Otherwise, probably GeoPackage, better option.
Yeah, I would say GeoPackage is, as a universal data exchange format, the best.
Yeah. And then the GeoPackage you can just do like a SQL query. You don't have to load it all in memory. But what about flat GeoBuff? Can you also query it, or without loading into the memory, to get a piece?
In theory, it has, you can query it with a B-box, basically, a bounding box. You can in theory, but then that's not possible when you do the data streaming. So then you have to read everything at once. That's a trade-off, basically.
Okay. The other thing we spoke about, like writing modern scientific papers. You know, the people used to like use a type machine first to write scientific papers, and then they will put pictures on the end, attach it, and then send it through regular mail. Then we had people still writing Microsoft Word. But we think like the future will be these computational notebooks, and that all the plots will be interactive. And so your mapview package could be a solution to make basically anything where there's geographical data to be embedded in the paper and to be interactive, so people not only see one view, but they can make their own view. What do you think about these developments?
For the open publishing, yes, because the one thing you need to realize, everything that you see in the browser is attached to the browser. So all your data is accessible, even if you don't know this, right? So it's only an option for open publishing, basically. But yes, I agree. And that's why I put effort into support Markdown and all those notebooks. But it's a bit of a tricky one because you always have to, there's a few more hoops that you have to jump through. For example, at the moment, you cannot use flat GeoBuff with Markdown because Pandoc, which is the renderer for the whole Markdown thing, does not know the MIME type of .fgb because it's not implemented there. And Pandoc is a community that is so far detached from anyone that I know that I don't know how to get this in there, basically. So there's still some time needed, I think, for the flat GeoBuff to be accepted. But yeah, I agree. Interactive online papers are a lot better than just paper-based ones.
And so, like, let's say when you make your map view with the leaflet and basically it's HTML, what happens if you're offline? If you're offline, then it's a blank screen. Is there any solution then also for the offline viewing, or?
Well, for the offline viewing, the only thing that's missing is the background maps, basically. Or
Okay.
if you load Cloud GeoTIFFs from a URL. But all the other data should be locally and you should be able to view and interact with it.
Okay, well, these are my questions. I did a bit of shootout. Are there any still questions by the audience, maybe? So then one more time, we'll see you in half an hour. We look forward to your talks and tutorials. And thank you so much for dedicating this time. And I also thumbs up also from my side, great package. And you made life easier to thousands of people. So thank you so much in front of the community. So we see you in half an hour.
See you later. Bye-bye.